Welcome to Lesson 2 of Forces of Motion. Today we will analyze Newton's first and second laws of motion. You will need your teacher-made packet for this lesson. Please turn to page 4. To save time, I'm not going to read this with you. I would like for you to pause the video and read the interview, Down with Gravity. It's an interview with Newton's apple. Please do so at this time. Newton's apple can get pretty sassy sometimes. Now on page 6, you will see at the top of the page it says, today we will analyze Newton's, this is still yet first and second laws of motion, and we're going to do the word web for inertia. Inertia is the tendency of an object to keep moving in a straight line forever. This is like when you're sitting in a car and the driver gives it gas and you'll feel yourself be pulled backwards. Your body wanted to stay still while the car started to move. The same thing applies when the driver hits the brake and everything in the car goes moving forward. This is inertia. Your body was moving at the same speed the car was moving at, and the car is wanting to stop, but your body is wanting to keep going forward. Same applies when going around a curve and you fall over in the seat. That's inertia. A great way to practice the word inertia and to remember it, your parents may get a little upset with me, but whenever they hit the brake or give it gas and you feel your body move, going around a curve or a turn and you feel your body move, shout, inertia! And it's just you helping practice the word and you will remember the word a little better. Now at the bottom of the page, you see this article. I would like for you to pause the video and read this article. And then when we resume the video, we'll have a brain pop video to watch.
Can you please stop telling Houston that we have a problem? Wow. Dear Tim and Moby, who was Isaac Newton? Sincerely, Dylan. Sir Isaac Newton was an English physicist, mathematician, astronomer, and natural philosopher. Well, you don't get a reputation as one of the most influential figures in the history of science by being good in just one subject. Newton was born in 1643 in the town of Woolsthorpe by Colsterworth. That's where he would do some of his most famous work, including helping invent calculus and coming up with his theory of universal gravitation. But before that, he almost became a farmer. At age 17, Newton was away studying at school when his mother ordered him back home to learn the farming trade. Luckily, the school's headmaster convinced his mother to send Newton back. After finishing with high marks, he enrolled at Trinity College at the University of Cambridge, where he studied for the next 4 years. The school shut down in 1665 because of an outbreak of plague, so after getting his degree, Newton went home to continue his scientific explorations. Yeah, that's where he saw the famous apple. According to legend, Newton was sitting by his window in Woolsthorpe Manor when he saw an apple falling from one of the trees in his garden. That got him thinking about the mysterious force that pulled the apple to the ground, and whether it was the same force that kept the moon in orbit around the Earth, and the Earth around the sun. Newton decided that it was, and this force, which he called gravity, affects every object in the universe, depending on its mass and distance. Hey, watch where you're going. So, in 1687, Newton published this universal law of gravitation. It was in a book called the Philosophiae Naturalis Principia Mathematica, usually just shortened to the Principia. Newton also used the Principia to unveil his other major contribution to physics, his 3 laws of motion, which explain how and why stuff moves. You can find out more about them in our Newton's Laws of Motion movie. But physics was just one part of Newton's work. He was also pretty good with numbers. He's one of the inventors of calculus, the kind of math that lets us measure curves and irregular shapes. And then there's Newton's work in optics, the branch of physics that deals with the properties of light. By refracting light through a prism, he discovered that white light is made up of a whole spectrum of colors. Using this discovery, he invented a new kind of telescope, the reflecting telescope. Back then, refracting telescopes formed images by using lenses to bend light, resulting in a lot of the colors being lost. Newton's reflecting telescope avoided this problem by using mirrors to reflect light, resulting in a much higher quality image. Yeah, he was eventually knighted, but it wasn't for his contributions to science. Newton received his knighthood as a reward for his work as the Master of the Royal Mint in London. He used his position at the Mint to completely reform English currency, and he devoted a lot of time and energy to punishing counterfeiters, too. Of course, he'll always be known for his scientific work. In 1703, Newton was named President of the Royal Society, the most prestigious organization of scientists in England. And when he died in 1727, he became the first scientist to be buried in Westminster Abbey, the famous church where English monarchs are buried. But his long list of discoveries, theories, and laws lives on, becoming the driving force behind the scientific revolution and inspiring future thinkers. Once people realized that the inner workings of nature could be revealed through rational and universally accepted scientific methods, all sorts of doors were opened. No, not that door.
Page 7 of your teacher-made packet, you have the lyrics to a song called Laws of Motion Rap. I'm getting ready to play this for you on YouTube, and you are to go through this and write down what you think each of Newton's laws means. Please do not Google this. Please do it on what you think based on what is said in the rap. No right or wrong answer at this time. It's just getting your thoughts on paper.
An object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion continues in motion unless acted upon by an unbalanced force. Let's say you walking down the street, cause you going to the mall, and something knocked you off your feet, cause you ran into a wall. So you were acted on by an unbalanced force, which means you ran into the wall and it threw you off course. Oh, I get it now. An object at rest will remain at rest unless acted on by an unbalanced force. Yeah, often called the law of inertia. Yep. Bradley, come tell him about the second
Come
law.
on. Force equals mass times acceleration. What? Say I had to push a car to the gas station. It weighs 1,000 kilograms and rolls really slow. What? So it would take 50 newtons just for it to go. For real? Oh, I get it. Acceleration is reduced when a force acts on a mass. The greater the mass of the object, the greater the amount of force needed to accelerate the object. Law number 3.
According to Newton's third law, for every action there is an equal and opposite reaction, which means when you push an object with force, it pushes back with equal force, such as a rocket or a scooter. The rocket pushes down on the ground while the ground pushes the rocket up with equal force. And those are the 3 laws of motion. Yeah.
Now I would like for you to go to Google Classroom and answer these 2 questions. There's already a post made about it. You'll just need to type your answers and turn it in and then resume the video. On page 8 of your teacher-made packet, you have Describing Motion, Newton's Laws. We're going to keep coming back to this page a couple times, but first of all, let's talk a little bit about Newton's first law. When an object is in motion, it wants to stay in motion. When an object is at rest, it wants to stay at rest forever. This is called inertia. So I would like for you to write that beside first law of motion, law of inertia, in the box to the right. You may pause the video and write that down. Then we have Newton's second law. Newton's second law says when two forces on an object are balanced, the object does not move. When the forces are unbalanced, the object moves. And I'm sorry, that's messed up. I will fix that in just a moment. You may pause the video and begin writing while I make that correction. Better. It says Newton's second law, when two forces on an object are balanced, the object does not move. When the forces are unbalanced, the object moves. You may pause the video and make sure you have all that written down. We'll come back to this page to get Newton's third law later on in the video, in the series of videos.
Thanks, Moby. Hey, Tim and Moby. Can you tell me about Isaac Newton's 3 laws? From Jerome. Well, Isaac Newton was a scientist who lived in the 17th century. We have a whole movie about him, so you should check it out. Anyway, Newton came up with the 3 laws of motion that can be used to explain how and why stuff moves. Well, yeah, these laws are still in use today, so I'd say he was pretty smart. Newton's first law states that an object in motion will stay in motion, and an object at rest will stay at rest unless an unbalanced force acts on it. You probably don't think about it this way, but when a car is moving, everything in it and on it is moving along at the same speed. If the car has to stop suddenly, the objects in and on the car will continue moving forward. Guess we should have tied those on tighter. An object's forward motion will continue until an unbalanced force acts in the opposite direction to stop it. So, our seatbelts provided the unbalanced force that stopped our bodies from moving forward. But those ropes didn't provide enough force to balance out the ski's forward motion. Why didn't it keep going? Well, in this case, the force acting on the rock was friction. Friction is the resistance caused by any two objects in contact, and it always acts in the opposite direction of the motion. Newton's second law says an object that has an unbalanced force acting on it will accelerate in the direction of that force. When you're just sitting there, two forces are acting on you all the time. Right now, gravity is pulling our mass toward the center of the Earth, and the upward normal force of the ground is pushing up against gravity. We could sit here all day and go nowhere because these two forces cancel out. This hill is a different story. At this angle, gravity and the normal force are not canceling each other out. Gravity wins, and we accelerate. The net force that's acting on us and making us accelerate is a combination of the normal force and gravity. Look, friction! Newton's third law is this. Forces always occur in equal and opposite pairs. When I pushed that door, it pushed right back at me with equal force. The door was the one that moved because friction between my feet and the floor combined my mass with the building's mass. The door is on hinges which decrease friction, so it accelerates open. Maybe if you took off your roller skates. Or not. Oops. Well, that's about it for Isaac Newton's laws of motion. I'm gonna get Moby an ice pack.
Due to the length of this lesson, there will be a part 2 to this lesson, so make sure that you find it and watch it as well. I'll have it posted as soon as I record it. Thank you.